Hi, welcome back to the shop. Remember my new RF45 mill, or Optimum MB4 as it's sold here in Germany. I'm pretty happy with this milling machine, apart from the depth stop of the quill. The stock depth stop was pure crap. It's the adjustable type with a threaded rod that you can turn and you move a nut up and down, and this was just a pain because it had a lot of backlash and absolutely no precision built in it. And I changed it. I have a new depth stop with a dial indicator that shows me what happens, not only that I something to bump on, it actually shows me when I reach the end or the stop. And I didn't film the building of the step stop, but I have some picture that I want to show you, and then I will show you the operation of the step stop. Okay, in this first picture you can see the original depth stop with the threaded rod that's hinging up into the main casting of the milling machine, with the stop block on its end that moves up and down the threaded rod. Here is a better picture where you can see it a bit closer. The two switches are the limit switches for the threading cycle. And I want to keep that functionality with my modification. Here I have taken off the ring of the quill, and you can see the threaded rod in front. The threaded rod is has a plain bushing or bearing in the ring with about 0.5 millimeters of axial play, and this just doesn't work right because of the backlash in this bushing and also in the backlash of the screw. I started to mess around. I found out that the hole in the casting of the head casting of the milling machine is bored to pretty precise 16 millimeter. So I could stick up a 16 millimeter oilite bushing in there with a 10 millimeter bore, and then I could run a piece of 10 millimeter drill rods through it, which I mocked up in this picture. And that was the decision for the direction to go with this modification. And then I realized that with a 16 millimeter bore in the head casting, I could also use a piece of 16 millimeter hardened and ground guiding rod. And that was a super close fit in the bore of the head, and I was able to mount it to the ring on the quill, and so I had a rigid connection between the quill and the guide rod. In the second picture you can see the quill in the upper position, and that the hardened 60 millimeter shaft is actually touching the upper limit switch, which is what I wanted, because this defines the upper position of the quill when you're threading. But there was a problem. Now we are looking down onto the bottom of the head casting, and as you can see, there is no real flat spot where a stop could hit on. And also the limit switch was in the way. I turned a disc of out of mild steel with a 16 millimeter close fitting bore over the shaft and a flat surface, and that would give me a nice even surface inside the head casting where I could let my my depth stop block hit on. But I needed a way to mount this disc square to the shaft into the housing. And the solution, of course, as always, is glue. I used steel-filled epoxy To glue the disc in place, I put some mold release on wax mold release on the shaft and into the bores of the head casting end of the disc, and then I cast the steel disc with the epoxy in place. After the epoxy set, I removed all the mold release, and I had a perfect square surface for a stop to hit on. And then I made this prototype of a depth stop, which is in fact a piece of 40mm mild steel drilled for the 60mm guiding shaft and drilled to hold a dial indicator. Here you can see the depth stop in detail. The lower half is slit, drilled and tapped, so I could clamp it on the shaft. And here you can see it in position with a quick adjustment clamp handle. So you can adjust the depth stop very quickly on the 60mm guide rod. Then I enlarged the cutout in the front plate of the head casting, which is just a 3mm sheet metal cover. And then I mounted it back onto the machine, and you can see in the upper half that there is the limit switch visible. I have to add a piece of sheet metal to cover this up so it's not so exposed to the shop environment, but we will get there. Okay, now we're back in the shop, or in real time, and you can see the whole setup here. I have my dial indicator in the stop block. The stop block is quick adjustable in height, like this, and clamped in position like this. And you can just go down with the quill and hit your lower end. And the nice thing, normally with a depth stop, you have to rely. You just have to rely that you hit the lower end. But if there is a piece of metal, swarf, dirt, or something, you don't hit the end, but you don't realize it because you have no way to show it. But with the dial indicator, I can always go down to 0, and every time I hit the lower end, the dial indicator has to show 0. Then I know that I hit the lower end. And this is super precise setup with the 60mm guide rod in here. This whole setup is very rigid, and also the other nice thing it did, it stopped the quill was able to rotate in the housing slightly. This is not a real problem, but it bothered me. Normally the quill is stopped from rotating by a set screw that goes into the side of the quill into a slot, but that's a pretty crappy solution. But that problem is gone because of the 60mm guide rod. That it's rigid. It's a nice solution. And the other nice thing is, this is not only a depth stop for drilling. I can use it. I wanted to have a flat surface down here, so I can machine very precise with very precise C tolerances. I can set up the stop with gauge blocks and then just go down until I hit my stop and know that I'm the given dimensions that I have set with the gauge blocks down. It's I saw this setup on a jig borer. I think it was a Moore jig borer, and they had a pretty similar setup like this with flat surface, a dial indicator on top, and you just went down until you had your 0. And also I can use the dial indicator with the fine feed for very fine adjustment. Okay, let's do an actual demo. I have my Mitutoyo dial indicator down here, which shows the movement of the quill. Stay with me. I want to machine a pocket that's 9.55 millimeters deep. And I have a gauge block stack here that's exactly 9.55 millimeters. 9.55. And we will use the depth stop to do this. First we will touch off on our part, which I will do by zeroing the dial indicator down here. Let's just move down until we hit 0. Okay, now we have our end mill on the part. And now we release our depth stop, move it up, out of the way. Make sure this surface is clean and also that our gauge block stack is clean. And then we will release the clamp of the depth stop. Move it down. This is a bit awkward because I have to work around the camera. I have to do it so you can see it. And I let the depth stop go down onto the gauge block stack until the dial indicator reads 0. And then I will clamp it. And there is half of a hundredth of a millimeter tolerance because and now I have removed the gauge block stack. I've clamped it firmly and the quill lock is still open. Now I will just crank it down until I hit my end, the end of the travel. There we go, 0, 9.548, so 0.02 of a millimeter off. About, yeah, maybe. Yeah, of course, measuring 1/1000th of a millimeter in a shop environment is pretty much impossible. I would give this a good solid plus minus 1/100th of a millimeter, maybe a bit better. But to be realistic, 1 or 200ths of a millimeter is in the realm of possibility with the setup. The gauge blocks are precise, the dial indicator is good, the whole setup up here is rigid, and it works. And now we can check the repeatability. I will retract it and go down again until we hit the stop. 9.547. So that's basically the same as before. And just for fun we can do it again. 9.55. And one more time. 9.550. Yeah, that's the depth stop. I will change the screw. I will make it a bit longer so I can reach in a bit better. And I will repaint the squill ring because the color is awful. And yeah, apart from that, that's the depth stop, the modified depth stop of my milling machine. I hope you enjoyed. Thank you for watching. See you next time.